Hello everyone, Mr. Schultz here for Integrated Math 1, and we're doing 11.3 two-dimensional figures. Ooh. Make sure that you understand this is part 2, and that you have to write your first and last name at the top, as well as your period number. So, hey, we're going to be dealing with the shapes. So, for example, we might have a circle or even a semicircle on top of say a triangle. Hey, look, it's a cone, an ice cream cone. So if we're going to analyze some shapes, we have to break it down to its parts. So in an ice cream cone, it's a semicircle plus a triangle. Maybe we'd have, in a house or a room, we have like an L-shaped room. Well, we could cut it, and then that's equal to two different shapes added together. And so normally, if we're trying to figure out what is the area, we have to break it down and figure out, all right, it's from here to here, which is half of a circle. And then we're not going to find the total area. We're going to only find these sides. Or, I'm sorry, the perimeter. Sorry, mixed up perimeter and area for a second. So let's do a couple examples. In fact, we're going to do 3, and then you're going to complete the rest. So example 3. 10. Dev is designing a new sign for his art studio. However, he needs to make several improvements to the sign before it is ready to be hung. Dev wants to add a metal trim around the perimeter of the sign. How much trim should Dev purchase? Well, looking at this, we have to figure out how much does he need? Well, I know that he's going to need 2 plus 2 plus 7, 4, 11, plus 3.5 and 3.5. Well, that's 7. 7 plus 7 is 14, plus another 4 is 18, plus whatever half of the circumference of the circle would be. So the circumference, so we want to find half of the circumference, which is equal to d pi. So half of the circumference is equal to half of d pi. Well, the diameter of this is, well, what's the diameter? Well, we have to use what they give us. So since I know the total is 7, this part is 4. So I know the diameter is 3. So I would take out my handy dandy calculator and do 3, well, turn it back on, 3 times pi divided by 2. So it's 4.7. So 4.7 plus 18. So the perimeter is equal to 22.7 centimeters. Or no, not centimeters, feet. Sorry, my fault. Well, round to the nearest foot. 23 feet by 23 feet. Round up. Next up, the front of the sign also needs to be waterproofed with a protective sealer. How much area needs to be covered by the sealer? Round the answer to the nearest square foot. So we have to figure out the rectangular area of the rectangle plus the area of the semicircle. Okay, well, this is 7 times 3.5, and the area of this is half of pi r squared. But r squared, the radius, was 3. Well, the diameter was 3. The radius is 1.5. So this would be 1.5 squared. So, using my handy dandy calculator, I would just go clear it up. 7 times 3.5 24.5, so I write that down. So this is the rectangle, 24 feet squared, plus the semicircle. So I could just type it in, 0.5 times pi times 1.5 squared. And it gives me 3.53. So I'll put 3.5. Feet squared. Now if I add these together, I'll get 28 square feet. There you go. So, last one. If a pint of sealer covers an area of 20 square feet, how many pints of sealer should Dev purchase? Well, I mean, he has to buy 2. Dev needs to buy 2 pints. Now, he'll have some left over. I mean, technically, if we wanted to, we'd be like, all right, how many pints does he need? And we go 8 over 20 is equal to divided by 4, divided by 4. We get 2 over 5. And if we divide that out, we get 0.4. I mean, technically he needs to buy 1.4 pints. But we don't know how much can he, like, he's not going to buy a bag full of it and be like, all right, just fill this bag. You know, he needs to buy a can. And how much is in a can? If it's a pint, then he's just going to buy 2 pints and that's it. He can't deal with it. Like, he'll have extra. That's it. All right, let's go on. The world's largest ice cream cake was created on May 10th. Well, forget that. I don't even know that. So it was 4.4 meters long and it was 4.06 meters wide and 1 meter tall. Oh, well then let's draw it in. It was 1 meter tall. All surfaces of the cake except the bottom were covered with cookie crumble topping. Use an approximate 2-dimensional model to approximate the area covered by the cookie crumble topping. Ooh. So I'm going to draw it out and I'm going to show you and explain to you. All right, guys, here we go. So we have the top, which is 4.45 meters by 4.06 meters. We have the sides. So it's 1 meter tall. So if this was looking down on it. Now, if we took up the cake and looked on the side, it's 1 meter by 4.45 meters. And there's 2 of them. So we have to times this by 2. Now, the reason why we're not timesing this top by 2 is because it says, hey, not the bottom. So it's the top, the 2 sides, and the 2 end pieces. Now, the end pieces is going to be, like if we looked on the side, on the end, it'd be 1 meter by 4.06 meters. And we times that by 2. Well, what are we going to do? Well, these are going to be nice and easy. We're going to get like 8.9 meters for square meters, plus this is going to be 8.12 meters squared. The only one we're going to have trouble with is this last one right here, which would be 4.06 times 4.45. So I'm going to put 4.45 times 4.06. And we get 18.1. And so we get 18.1 square meters. And if we add each one of those, we get 9 plus 8, 17.02. We get 17 plus 18, 36, 35. 35.12 meters squared. So we had to think for a second and be like, all right, how many sides do we have? We have the top, the two sides, the two end pieces, but not the bottom. And there we go. All right, one more question, and then we're left with you guys to finish it up. So it says, 8-ball pool is a popular game with a pool table that has 6 pockets. In the 8-ball pool, there are 7 striped balls, 7 solid color balls, and a black 8-ball. At the beginning of the game, each player positions the 15 balls in a rack in preparation for the first shot. Find the area contained by the rack using an approximate 2-dimensional model. Round the answer to the nearest tenth of a square inch. Okay, so hold up. Now, I was getting a little frustrated here. I was like, well, how do we get this information? And then I looked and I was like, oh, that makes sense. I cut out the information from you. It's in a triangle. It's like the height, it shows you that the height is going to be 9.96 inches. And it says, hey, from here to here, it's going to be 11.5. So yeah, we couldn't really do it. It says find the area contained by the rack. Well, the area of a triangle is 1/2 base times the height. So 1/2 11.5 times 9.96. How do we do that? Take a calculator, guys. 9.96 times 0.5 times 11.5. Get our answer of 57.27. So to the nearest inch would be 57, going down. Round down. 57 inches. Approximately 57 square inches. Wait. Yeah, square inches. Approximate area covered by a single ball to the nearest tenth of a square inch. Well, I'd probably just take, and looking at this, now this one's a little bad for this, but there's 5 balls that go across, 11.5. So I do 11.5 divided by 5, which would be 2.5 is equal to the diameter of each ball. So approximate area covered by a single ball to the nearest tenth of an inch. Well, remember that the area of a circle is pi r squared. So 2.5 squared times pi. So I do 2.5 squared times pi. And we'll say our area of one ball is 19.6 inches. Squared. All right, guys. Sorry I forgot about the image, but go ahead and finish up this. And I hope you guys have a wonderful day. I'll see you tomorrow in class. Bye, everybody.